technically by 1 p.m., but you better have it done before you start taking your test. The practice test, is it required? No, but if you do poorly on the test and if you don't do the practice test, what's my first piece of advice going to be? You should have done the practice test. So the book is helping you review the concept, the book review that we're going to go over now. And the practice test is giving you experience with multiple choice questions and how they can get tricky when they're all mixed together. They're not going like from section to section. Bless you. When the answers, there are multiple ones that look good, which one's the right one, etc. When the wrong ones are staring you in the face and you're like, oh, but it looks so nice, I just want to choose that, but it's a hole, and so the limit does exist, or whatever the question may be. So our goal today is to go over the review questions that you have from your attempting and grading, ones that you got stuck on or you don't know why you got wrong or how to do it right, all the above. Then at the end of class, if there's time, we can go over the practice test as well, questions that you guys have gotten stuck on. But I don't want to do too many of those as an entire class because some people haven't been able to try it yet. And so if I just go showing them solutions, it's kind of like class time where in class I do examples and then you go to homework and you get stuck. I don't want that to be the test. I don't want today to be all like me giving you stuff and then you not being able to practice it on your own. What is online in Google Classroom for the practice test? The key. And have you guys noticed the keys all worked out? Nick, I'm sorry.
Okay, I was just wondering if the practice test is like a good example of how many of each type of question you're going to do.
I would not necessarily say that. I didn't really pay attention to like proportions and yeah. No, I wouldn't necessarily say that. But there is going to be a smattering, that's the word. There's going to be a collection of all the different types, but I wouldn't necessarily say that's a good measure. But you could kind of look at the types of problems that are multiple choice versus the types of problems that are long answer and think long answer, maybe like an IVT finding C, maybe like a definition of continuous having to explain why or why not. You can kind of gauge on those as far as like which of these might be long answers too. Yeah, because long answers are usually choice and I grade on the work shown. Before we get too much into today, let's just really quickly, since your brains aren't overwhelmed yet with what we're going to be going over, because we're going to hopefully be doing just tons and tons of practice today, let's talk about the format for tomorrow. So first thing, Hannah, is it for senior guys? Oh, nope, it's not. Joyce and Ruth, student council people. There you go. Let's talk about tomorrow, the testing experience. Some of you have had me before and some of you haven't. So let's go ahead and talk about tomorrow. What do you need to have ready for me tomorrow in hand when you come into this room? Homework spiral. And we talked about yesterday what I'm grading on. Your notes, your composition book with someone from last year. What can you forget sometimes? The table of contents and the page numbers, and if you've been gone, all the notes have been taken. Hopefully it's super obvious as to why I require that on test day. Hopefully you've gone over notes from every section, even if you've been gone. Notes, homework spiral, we're going to make 2 piles up here at the front. When you guys finish your test, your notes will probably be on the baby table. Your notes will be all spread out. Pick up your composition book, your notes, before you leave the class. The homework spirals probably will not be ready until the next day. Okay? When you finish your test, let's just talk about very beginning, very end. Oh, hey, what did I not mention? Pencils, erasers, cover sheet, which I'm going to have you guys have out either your 0 period or your tutoring form, either yellow or green. Have you have one of those out for a cover sheet. You can also have out a blank piece of paper if you need, just in case. Where do I want most of the work to be shown? On the test itself, but don't I realize that some problems you might want more? And some of you just hate and you want to have it nice and spread out. That's fine. But if I'm going through grading the test, multiple choice, sometimes on one that's commonly missed, I might look at the work. And depending on if you were close, sometimes I give partial credit, like I did in pre-cal. Every now and then I gave partial credit on multiple choice. Actually, fairly frequently. I gave partial credit on multiple choice too. The AP doesn't do that. The AP does right or wrong, but we're not at the AP yet. So. Have your 0 period and or tutoring form. When you turn in your homework spiral, keep one back. If worst comes to worst, there's extra ones back there. I guess you could just go pick one up and use one from back there. That's okay too. You can also have blank piece of paper out also. I'm going to have you guys do this number with any pieces of paper, allowed pieces of paper that are on your desk before the test. Oh, hey, what's not even supposed to be in your vicinity that you almost have with you every day? Okay, so when you walk in the morning, just put your phone in your seating chart. You can go scope out which seat is yours right now. But phone is in there before you even walk in. So phone is in there. Homework spiral and composition book are turned in up there. On your desk, you have either a 0 period or a tutoring form along with some scratch paper if you need it, and a pencil. What did I not mention? Calculator, because it's not necessary for this test and it's not allowed for this test. And maybe you know that, because if I was to allow it, you could theoretically plug all of these into tables and then make educated guesses. And number one, you would get problems right that you shouldn't have, because the AP has non-calculator sections. And number two, it would slow you so far down that you wouldn't be able to finish the test if you did it that way. So no calculators tomorrow. Okay, so far in our minds, we're doing like a walkthrough. You guys do that for games, you do it for meets, etc., right? You guys have your desk cleared and you're ready to go for the test, true? Pass out the test is going to be about the same length-ish, Nick? The same length probably as the practice test, in the sense of 2 pages, front, back, multiple choice, probably a little bit more multiple choice, long answer. I think that's similar to the practice test. Strategies. Some of you should start on the long answers while you're fresh, while you're ready to go. Some of you should start on the long answers. Some of you should just start the multiple choice and bust your way through. But what no one should do is get stuck on a problem that's taking them too long. Okay? In the AP, sometimes you just have to cut your losses and move on and hope that you can get back. Why? What if you spend so much time on a hard problem and then all these ones that you could have done really well on and never got to, you miss automatically? And maybe you miss this one after all anyway. Okay? So when you look at a problem, if you know what to do, if you know what to try, start it, try it. But if it's taking you more than like 2 minutes, 2 or 3, you gotta cut your losses. Maybe make a guess, put a little star by it, and move on. Why do I say maybe make a guess? What if you never get back to it? Multiple choice, at least guess. So maybe make a guess at the beginning, but I would definitely mark it in some way, shape, or form so that you can get back to it. Strategy-wise, don't you have a higher percentage of getting a question right if you're able to eliminate some of the options? Have you guys been using that on the practice test a little bit? Well, it can't be that one. It definitely can't be that one. So that's a smart thing, too, to show which ones you think can't be. Doesn't mean you're always right, but it is a way of narrowing down in order to have a higher probability of getting it correct. Okay. After you finish the test, you will go ahead and, actually depending on how it works out, as far as like how close to the end of the class period. It's going to be a little different this year in that you guys are going to go ahead and raise your hands, like covered up with your 0 period sheet or your tutoring form. You're going to raise your hand, get my attention. I'm going to bring you the quiz reflection, which has 2 columns on it. I'm going to take your test, I should say, and give you a quiz reflection. You're going to work on that until I say something to the extent of, oh, hey, there's only a few minutes left. Anybody who's turning their test, come on up and grab your notebooks. There might be a few people still working all the way to the bell. But the quiz reflection has 2 columns. The got it column, what you can remember from the test, the topics that you were like, oh, I nailed these. I know I nailed these. Like, I got them all right, or at least I think I do. I feel really strongly about. And then there's a still needs work column where you're like, oh, when I faced this one on the test, the intermediate value theorem, I was still stuck. Something like that, to the extent of what you got, what you didn't get. And then at the bottom it says how you studied. You're just going to give a quick little description of how you approached the test, how much time you spent on it, when you started studying. You're evaluating your own performance. It's a self-reflection, basically. And then right after that, it says action plan. Like, okay, based on what I just did, what I got, what I didn't get, how I studied, is there anything I should probably change for next time? Does that make sense? Okay, now on the back is going to be a brain teaser you guys can play with in the sense of like a mind puzzle. That I think some of you have already heard about, but that's no fun. Hopefully you don't know all the answers yet. And I'll put an example of the brain teaser up on the board so that you can, when you finish, be like, oh, that's what these are? Okay. Let's talk about one last thing. I talked about how you guys come in. I talk about how we get ready for the test. I talk about how we go through. Why am I saying all this right now? Time is precious on calc tests. You guys thought pre-calc was bad. So listen carefully. The faster we can get all this done, the faster we can start the test. But every time we have a calculus test, I also allow you guys to come 15 minutes early to start the test. If you don't come early, you don't get extra time. And just think about students, think about teachers, think about how the pressure to do well would lead a lot of people to cheating if I was to make any other way possible. So there is no coming in during lunch or after school to finish a test. That's not a thing. Okay? But I do allow you guys to come 15 minutes early. What does that mean? For you guys, you can come at 7:45. You can come at 7:45. So some of you need to plan ahead. Some of you need to talk to parents and carpools, etc. You can come at 7:45 in order to start the test. You can get into the room, I should say, at 7:45. You can't start the test until 10 till or until 7:50, and here's the reason why. Our class is 5 minutes longer than period 6. So we'll have 10 minutes and then the extra 5 minutes. Period 6 is going to come lunchtime 15 minutes early, start 5 minutes in, or I should say they'll come 15 minutes into lunch, because then they get the passing period, the 5 minutes in between lunch ending. That's like your extra 5 minutes of class, and then they have the same amount as you. So I make it super, super consistent. Both classes will have the same amount to take the test. When you come in is how much time you get. Does that make sense? Okay. If you come at 7 in the morning, am I letting you start the test? No. I have a meeting at 7:30, so literally I like book it out of the meeting. You guys are here. It might be your 46, 47. But you guys will have all your stuff. You'll be ready to go. Come in, get everything situated. And then if you're ready at 7:50, you guys don't even need to sit. Actually, I don't even want you to sit in your normal seats. Do you see how many empty seats there are out here? Tomorrow I want us to spread out. So you're not going to be allowed to be horizontally or vertically next to anyone. You're going to be diagonal all around the room. You can even use the TA desk in the back, whoever gets to it first. That's Maggie and George's, but for you guys, I don't know who's going to claim it this year. All right. Sound good? Any questions about all the formatting of tomorrow? Ryan?
I can't speak.
That's okay.
Are you allowed to replace your lowest test grade this year?
Yeah. Each semester you can replace your lowest test score with the final exam. Yeah. Yeah. But don't bank on that too much. All right, any other questions? Let's bust out as many practice problems as we can, as many questions as we can, as many clarifications as we can. If I were you, I would get out a different colored pen. You were probably grading in one color last night. Maybe get out a different color, because I will show you what we went over in class. If I do any explanations, if I do any clarifications, if I do any hints, et cetera, et cetera, et cetera. But you might want to grab out a colored pen. Otherwise, maybe you want to grab out your notes in case there's something that I refer to or allude to. I would love for us just to have some work time today. Some of you guys got it in 0 period and some of you guys didn't. So that's why I'd love to be able to offer for everybody a little bit of class time to work. Ooh, sorry, really quickly, just because I know I have you guys in here. My or is it just you guys? Okay, here we go. Test review. I have all the answers up. You guys already accessed them. We could do the evens, the odds, whatever. What do we have? Any questions, clarifications that we need? Yeah, Patricia. No, go for it. I'm just going to circle them. Okay. 75. AJ, what do you got?
74.
That's it? Rachel. 78. Who else, David? 45. Who else? Jenna.
49, 57, and
Yeah, I got that one. Okay. Got it. Okay, Ali.
82.
Okay.
86.
Okay.
87.
Okay. Anybody else? It's okay. I was used to it. Let me take a picture. Oh, the rest. No, we're not doing that. Okay, let me take a picture of them. That way we can work our way through. The nice thing is for most of these, I think the answers are actually, not the answers, the questions are actually up here also. That's why I didn't stress about, there we go. Okay, making pictures of the book, et cetera, et cetera, et cetera. So the first one that I see is number 23 down here at the bottom. Let me go ahead and zoom in so we can see this as we go. 23 and 24, which we have both of these. Guys, real quick, does everybody need every one of these? No. What could you have out and be working on or continuing to work on for a question that you don't have the practice test? Yeah, bingo. So you can grab out the practice test if you want to have it off to the side if you don't need it, but you might still want to be listening in case I have an explanation that you didn't think of. Some of you sometimes do shortcuts that are quite illegal and magically happen at the right answer. Number 23 and 24, they both have trig. They both have trig. And not a lot of explanation as to why the answers are what they are. However, let me go ahead and show for 23 how I would do it. I would go ahead and take, first of all, why are we even doing anything besides plugging in? What happens when you plug in? Question, do you need to know your unit circle for tomorrow? Yeah. So plugging in 1 minus 1, cosine of 0, is 0, not 10. And then sine of 0 is also 0. So yes, it's 0 over 0, keep going. Hey, I think on a long answer, I might give you a point just for knowing it's 0 over 0, keep going, even if you get stuck on the rest. Okay. Now, some of you guys are looking at this, you're like, this is almost a property. And that's almost a property. Okay. Here's what they were in essence doing. They were saying there are different properties for each of these. So they split up the numerator and denominator. They split up the numerator and denominator and said, oh man, I really wish he had an over x, because that would be a special trig limit. Can we give him an over x? And the answer is yes, but we can't just put an over x. That throws everything off balance. But what could we do? Multiply by 1 creatively. And if we multiply by 1 creatively, this x should go right there, because that's a property that I want to be able to use. But the problem is I still have this x. So what they did is they went ahead and brought it to this piece, saying maybe he'll be helpful. And you guys could actually add this to your forever cards if it helps. It's one other thing to memorize. But technically, since, really quickly off to the side, since the limit as x goes to 0 of sine of x over x is 1, and since 1 over 1 is also 1, I could actually say that this is also true. And what happens with that is actually I could say this will be the exact same thing. So whether you have sine of x over x or whether you have x over sine of x, the reciprocal of 1 is 1. So technically, that is a special property also. If you don't like that description of it, technically what else you could do is you could say, he's the reciprocal of what I want. You could write that down and you could say he's the reciprocal of what you want. There's that special trig limit. Here's this special trig limit. But maybe for some of you, the fact that this one is 1 is not a big deal because this one is 0. And what, 0 times anything? Dun, 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 dun. So the 0 times anything kind of made it a little bit easier. Number 24 is super similar, except you look at it and you say, stink, plug in 0 over 0, keep going. Not everything on the test is 0 over 0. Plug in first. Some of them will just be numbers and you're done. But this one, do we have a special trig limit with tangent? But what do we have? We have one for sine. I'm going to pull that 4 out because I don't really like the 4. Wait a minute, pause. Wait a minute, pause. Didn't my warning fit this problem? What do I mean? We started thinking sine over cosine. We have to start pulling out the 4 and doing all these special trig limits, but what's the problem? It wasn't 0 over 0, keep going. Some of you just agreed because you're used to agreeing with me, and that's super dangerous. If you guys notice, tangent of pi over 4, isn't that a 45 degree? And doesn't 45 degrees have cosines and sines that aren't zeros or ones? And if you were to divide the y by the x or the sine by the cosine, square root of 3 over 3, 1. Square root of 3. You end up with pi over tangent of pi over 4 is 1. This was not a 0 over 0. Keep going. This was a plug and chug. Know your unit circle. Ouch. There it is. All right, next one. Number 45. Here he is. Limit as x approaches 2 of f of x. I'm guessing they gave you a graph? What did they give you in number 45? Piecewise? Okay. Opening it up real fast because that'll be easier than you guys trying to describe it piecewise. What was it? Page 118? Got it. Okay, number 45. You guys don't necessarily have to have it written down because it was a review, but it would have been helpful for something like this. Our piecewise function. Does anybody have it right there? They can read it off to me. X minus 2 quantity for x. Okay, and then the other one is just. Nick, you had a question. I'm sorry. Is it like an earlier? Yeah, why don't you wait for just a little bit? Thanks, bud. But if I were you, I would skip it and move on just in context of tomorrow. Guys, if we need to go towards 2 and we have a piecewise function, is it enough just to come from one direction? No. Is it enough just to say the at and plug in? No. Any one-sided, or sorry, any limit needs to have both sides agree. And so if you were to show all the work for this, you would come from 2 below and come from 2 above. This type of piecewise is one where you have one branch on one side, one branch on the other. This guy is a less than, so he's the below piece. This guy is the greater than, so he's the above piece. And how do we find limits? 1.9? No. The below just says to plug into him. We always start by plugging in what? Always plug in 2 and see if it's an answer. 2 minus 2, that's 0. It's an answer. Plug in from above. What is it? Do they agree? Limit exists. Dun, 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 dun. What if they didn't agree? The limit would not exist. AJ. Two minus 2 is 2 minus. No. The limit, we don't stress about the at. We don't stress whether or not this has a hole or whether or not it has a filter. We don't care. We're just looking at the branch and saying, if there was a 2, where would it be? Because that's the approach. Number 49 gives us a function. We're trying to look for discontinuities. I think Joe said it this morning. He was sitting up here. He said something about discontinuities. Look at the denominator. Yeah, because domain problems will be discontinuities. So denominator can't equal what? 0. So what did they do? They factored. And they said pull out an x and then x squared minus 1. So it ends up technically being, if you hadn't factored out the x, you would have x times x minus 1, x plus 1. My zeros are going to end up being x equals 0 and plus or minus 1. And they were asking for which ones are removable, which ones are non-removable. The removable ones are the cross out. So when you x equals 0 is the removable discontinuity, aka the whole, aka the 0 over 0, keep going. But plus or minus 1, they don't reduce, so they're non-removable. Their limits don't exist. Their limits would be infinite. I don't like the way they described it. You can just say they factor out. They're non-removable. Were you supposed to find the limit? Did they actually tell you? Okay, then don't stress. They're giving extra information, Janelle. A great question. Let's look at this one real quick. Here's another example from, is it the review, the practice test? Review, must be. Number 78. And I think someone had this question, so if you wouldn't mind peeking at 78. This one has a 0 from below. But always at the beginning, always just plug in the number first. Don't worry about this until you're checking signs. Unless you're thinking piecewise functions. We did have to think about above and below, not doing 2.1, not doing 1.9, but just figuring out which piece. So we had to think about this for which piece, but otherwise we were just plugging in 2 if it worked. For this one, I don't even know about the piece, but I'm plugging in just to get an idea of what's going on. When I plugged in, I figured out number over 0. It was infinity and beyond. I went ahead and just wrote this to say the 12 wasn't the problem. The E isn't the problem. This is the guy we got to figure out. And we know he's infinity and beyond. So then I said, To check the sign, I need to think exactly the values on this side. So to check the sign, I was like, oh, 2 is always a negative. Negative 0.1, negative 0.01, negative 0.001, those are all negative. That got me to my positive infinity. So I thought about the sides for checking the sign, or I think about the sides for picking the piece. Does that make sense? Okay. Number 57, 58, 59. We don't like these ones. Are these more discontinuity ones? Discontinuity, you guys see what they're doing? They're just looking at the denominator and saying, hey, x can't be 1. X can't be 1. What kind of discontinuity? This was a piecewise, wasn't it? I feel like someone showed me this one. Yeah? Okay, hold on. It's not as easy as x. We have an x equals 1, and we have, right, an x not equals 1. And then we have our 3x. Forget that. Factor it. And what was the value down here? 0. 1 is a discontinuity, you would think. But here's the problem. If this graph, whoever he is, I don't really care right now, this graph, whoever he is, if he comes up, this part says, hey, everybody but, if this filled the hole, would there be a discontinuity? No. But if this doesn't fill the hole, is there a removable discontinuity? So here's the dealio. It looks like x can't be 1, but if he fills the hole, we're fine. So we have to figure out what's going on here, and does it agree? And how do we figure out if they agree? Definition of continuous. Does f of 1 exist? Yeah. Does the limit as x approach 1 exist? Well, below 1, above 1 is that guy. Guys, isn't it 0 over 0? Keep going. Plug in 1, isn't it 5? Condition number 3, does f of 1 equal the limit as x approaches 1? No. So is this discontinuous? Yes. What kind of discontinuity? A removable one. It's a hole. It's a hole. Number 58 is also asking about discontinuities, but here's the dealio with him. Do lines have any natural discontinuities, any domain problems? No. Does this line? No. So what's the only place I could have a problem? Separator. Do they match up or do they not match up? How do I figure it out? I come from below. Here we go, Janelle. I don't care about 1.9. All I care about is, are we looking at the right piece? Plug in 2, 3. I'm coming from above, looking at the correct piece, plugging in 1. Do they agree? No. Is there a discontinuity? Yeah. What kind? Non-removable. That's not a hole. That's a break. Non-removable. AKA, this one it was saying it's continuous on. You could have also just said it's continuous for x not equal to 1, all real numbers, and for x not equal to 2. You didn't have to do the interval notation. You could use the inequalities. Number 59. I know I'm going fast, but you guys have my explanation. You can slow me down in the video tonight if you want to go back over something, yeah? Number 59. Is this IVT? Sorry, I know it was on like the top of the world up there. Okay. F is continuous on the f of 1, f of 2. Oh, okay. Did they just give you the points outright? That was nice of them. Oh. Did they give you the -1 and the 13, or did they give you a function f? Okay, then pause. They gave you the interval. Basically, it's something about IVT. Does it apply to a function f on 1 to 2? Okay, you had to do some of that work. What was your function? Okay, does IVT apply? Well, hold on, IVT starts with an if. If a function f is continuous. Is a cubic, a polynomial, any polynomial continuous? Always. I can draw him, swoop, there he is. There's no vertical asymptotes, no holes, no denominators, no square roots, no logarithms. He's fine. He's fine. So is he continuous? Yeah. For all real numbers, and specifically on that interval on 1 to 2. Now figure out, is there a k within f of a to f of b? And how Do we know that? Don't we have to find out who is f of 1? So what they did is they plugged in 1 and they figured out that f of 1 is negative 1. They plugged in 2 and they figured out 8 and 2 is 16 minus 3, 13. So then they were able to go ahead and say, is k within negative 1 to 13? And what was the k they gave you? 0. So specifically, k, which equals 0, is 0 in between? So does IVT apply? Yes. Why? The two ifs were met. Did they not tell you to find C? Oh, okay. They gave you C. So if they were to ask you, like this wouldn't be a good long answer on the test. A good long answer on the test would say, check if IVT applies, and if it does, go find C. So then how would you have gone and found C? You would have said, well, then there must exist some sort of C within A to B such that f of C, which is 2c cubed minus 3 equals k. Isn't that just something that we solved by math? And what are the only c's that are allowed to stay by IVT? Only the ones in between. Does that make sense? So the negative, I think you would get plus or minus. No, you wouldn't. It's a cube root. Never mind. You would just get c is equal to cubed root 3 over 2. So that would be a good test way of asking it. Number 63. Are we looking for vertical asymptotes? Is that what's going on? Or trying to prove it's oh, Ryan, I'm sorry. Go ahead.
Sorry, just thought
Okay.
of it. For the test, do
Yes.
we have to show work by doing the K where you think brackets or?
Well, the idea is if I ask you to use the definition of continuous or to use IVT, you're going to need to show me, number one, your knowledge of it, like a forever card knowledge, but then also your ability to apply. So I guess you could even say oh, K is in between and use those words, and you're totally right, right?
Negative 1 is less than X is less than 13.
That's good, except you can't say X. You have to say K, because the X's are the 1 and 2. You could say something like Y, I suppose, like Y equals K. Use K, because that's the Y value. X is separate. Nick?
On the test, will none of these be an answer choice?
Could be. I know. It does make it hard, right? But that's why I gave you the practice test. That's why I gave you the practice test, is to realize that's a struggle, so you have to be solid on your answer. And there is the possibility that you're solid on your answer, and there's nothing either close, or there's something really close, and you're like, you're trying to trick me. Sometimes I am, and sometimes I'm not. But it's because I need to get you ready for the AP, guys. Number 63 is what we were talking about. You're just trying to do vertical asymptotes? I mean, long story short, without going too in depth, don't neither of these factor out? I mean, neither of these reduce? So aren't they both non-removable? Aren't they both vertical asymptotes? I mean, that's the long story short. I wouldn't necessarily ever make you write all this work just to say, hey, they're non-removable, because you can't remove them. Anyway, positive, negative 3, both vertical asymptotes. Sorry that the book made it look all complicated. Number 74 and 75 were our next questions that I saw. Okay, how many of you, be honest, look at this question. How many of you start stressing about 1.9 right away? That's it? Wow. Usually it's a lot more. If you start stressing about 1.9 right away, you've forgotten the most basic thing with limits. Always, always, always do what first? Just plug in. Not 1.9, plug in 2. And what happens when you do? Remember, you can get partial credit if you show me this. What happens if you plug in 2? Number over 0. And what have I been training you to think every time? Number over 0? Infinity and beyond. What do you have to do? Check the. Got it. So why was it a negative? When you plug in 1.9, now it's time. What's the sign of the top always going to be? If I plug in 1.9, I don't know what 1.9 squared is. Isn't it less than 2 squared, whatever it is? And if you don't like that, couldn't you have done x plus 2 and x minus 2? Instead 1.9, oh, it's a positive. 1.9, oh, it's a negative. Positive times a negative is a negative. Cubed roots is a negative. Whether you want to think about 1.9 squared, don't really do it. Please don't. Or whether you want to factor and plug in. Either way, you get a, what's a positive over a negative? Number 75, well, he's not a number over 0. What does he? Actually do it. What sign of 0? 0. All right, he was a true keep going, unlike that other one that was there for a very important reason. Not all trig are 0 over 0. Trying to give as many hints as possible, as many times until it sinks in. Some of you saw this and you're like, yay, pull out the 4, pull out the 5. That's actually illegal, so let me show you how this came about. This 5 times x is totally free to be pulled out as a 1/5, and we did this in class a few times, saying that 5 isn't cutting it. Sign of u over u, the 5 doesn't belong. But now, the 5's gone, but who's not there? What do I need? Special trig limit, sine of u over u as u goes to 0, right? Who do I want there? Can I somehow magically put a 4 in math? No, but I can put a 4 over 4. And then this coefficient, pull them out. So you get 4/5 limit as x goes to 0 of sine of 4x over 4x. If your u is 4x, just make sure it works. If u was going to 0, 4x would be going to 0, which means x is going to 0. That's a u going to 0. That's okay. In order for u to go to 0, x would have to go to 0, so we're okay. But we're only coming from what direction? Wait a minute. Both sides is 1. So one side, well, okay, one side both or something. And 4/5 times 1 is 4/5. That was just there to trick you. As u goes to 0, both sides, the limit is 1. The two-sided limit is 1, so that means each one-sided limit had to be 1 also. Special trig limit, 1 times 4/5 is 4/5. We already did number 78. It's up on the board. It was our number over 0, infinity and beyond. Infinity and beyond had to check the sign of the infinity, plugging in from below 0. But it was 12 times e to the infinity. Can you guys help me out real quick? This is a good problem, but some of you might have just guessed infinity as soon as you saw a number over 0 and been right. What would make the answer to this 0 and not infinity? Because e behaves two ways, doesn't he? Doesn't e to the x sometimes go to infinity and sometimes go to 0? What would have happened if I had asked for the limit as x goes to 0 positive? Would that have made a big difference? Because then this would have been infinity and beyond again, number over 0 when you plug in. And when you go to do infinity and beyond, wouldn't it be 12 times e to the negative 2 is always negative. Positive 0.01 would be a positive. This would be 12 e to the negative infinity. And what happens with negative infinity? Careful. Sometimes e gets bigger and bigger, and sometimes e gets smaller and smaller. Another way of looking at it is 12 over e to the infinity. Whether you think about e's graph going to negative infinity, or whether you think about negative exponents being, or putting that expression in the denominator, bottom wins. What are both of these approaching? 0. Just saying, e is tricky. Remember, e is tricky. What else we got? 82? Only 3 left. We're doing good. 82. Pause. Do you have to solve the infinity ones that way? No. Someone tell me how you solved it. Degree tests. As soon as you're going to infinity, horizontal asymptotes, degree tests. Who wins? Die. Right? Ratio of leading coefficients? Negative 4 over 1. Wait, check the sign. Well, A, there are no square roots. There's no absolute value, so you're probably fine. Just what to keep an eye open for. But you could check the sign. Negative infinity times a negative is a positive, but negative infinity is a negative. Positive over a negative, it should be a negative 4. Dun, 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 dun. Someone else on 84 too, right? No. 86, 87. 86. Why didn't we like them? Yeah, probably. But isn't it still a degree test? Okay. So what's the square root of a squared in general? Of 1 degree. 1 degree, 1 degree. It's really just a tie. So we know the answer is going to be a 1/2, but what do we need to do? Check the sign. Just think degree tests, always check the sign. So what happens if I plug in a negative and square it? Positive! What happens if I plug in a negative times a negative? So what's a positive over a positive? If I was going to positive infinity, it would have been a positive over a negative. Last but not least, why didn't we like number 87? Just look at it. Didn't like the cosine. Some of you guys might want to make a note of this. Cosines and sines going to infinity always lose. Cosines and sines always lose as you go to infinity. Why? They're just bouncing between 1 and -1. They're not much better than like a constant. But the x's are going to be the ones that win. Sines and cosines always lose. It's from this thing called squeeze theorem that they're squeezed between 1 and -1. Basically, they're stuck and they're never going to really contribute much as you go to infinity. So, degree test, 6/1, check the sign. Negative infinity times is a negative. Negative infinity plus or minus 1, whatever. Negative infinity is a negative. And a negative over a negative is a positive. Dun, 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 dun. Should know.
Checking the signs for 82,
Yeah.
seems like a -1. Would that have value?
No. Because the nice thing is with degree tests, we get to ignore everyone but the highest degree terms. Kind of like, did I use this illustration for you guys? David and Goliath, you're sending them out, like one army sends one army sends the other. You're just testing those two, not everything else. But you do need to keep track of what's going on to that term. Does that make sense? But yeah, you don't have to worry about the other stuff. Okay. We good? All right. We do only have minutes left, so I think maybe the best way of using time, some of you guys have been working on your practice test either during class or like 0 period or both. And so I'm going to just quickly pull it up just so we can use it as a reference. But are there any questions that I wasn't able to answer this morning? I'm just going to go straight to my answer key for us to look at if the board comes back to life. Michael. For those of you guys that haven't tried the practice test yet, you might want to do this like maybe in your homework spiral around the review so that you don't put the work on the test itself. You leave it clear for you to try later. But you might still want to write it down or check out the video. Number 8. Michael, first thing that you try, what do? Good. And what happens when you plug it in? 0 over 0. So when you have your 0 over 0, you got to keep going. Yeah? Now this is a summer review packet 1. What do you do to keep going when you have a square root? Multiply by the conjugate. And if every time you have a square root, you multiply by the conjugate, which means the piece with the square root. Oh, come on, please, please, Lord. Everything's hooked in. I know everyone thinks there's a cable dangling, but it's not. This is why I asked for a new computer last year. Oh, well. I don't want to waste your time. Okay, up here. Multiplying by the conjugate. Help me out, guys. It's x plus 9 minus 3 normally. Okay, limit as x approaches 0 all over x. Multiplying by the conjugate would be square root of x plus 9 plus 3. Think about it like a big old binomial. What you do on top, you do on bottom. Now remember, the nice thing about a binomial being multiplied by its conjugate is that ultimately you just end up with x plus 9 squaring the square root. The outer and the inner would cancel. It's a positive 3 root, negative 3 root. All over. Keep this guy. You have your limit in front. Wait, tomorrow on the test, what do you need? I was telling some of you guys in homework comments, what do you need to do step after step after step after step? Rewrite the limit until the final plug-in. Well, 0 over 0, keep going. Don't write limit there, but rewrite the limit until the final plug-in and solving. Michael, do you see how the 9 cancel? Now what's going to happen to the x's? Reduce. You get a 1 over. It's time to plug it in, plug it in. 0 plus 9 plus is 1. Good? Conjugate. Something else on the practice test? Oh. Got it. Plus 3.
Oh.
Got it. Got it. Ale, what do you got?
23.
Mm-hmm. Come on, team. So Keith, try that one. 23 is the definition of derivative difference quotient. How many of you guys like h's better than delta x's? Okay. So then if we were to do the h instead of the delta x, oh Lord. Ali, read me the function real quick.
As delta x approaches 0, x plus delta x quantity squared minus x squared all over.
Okay. As you guys are packing up and getting ready to go, you plug in difference quotient. We did videos, we did lessons, we did examples and notes, right? You can always go watch me more. But 0 over 0, keep going. How? You got to FOIL. Don't kill a puppy. And when you FOIL, when you actually think of x plus h times x plus h, you get this. And every time with the difference quotient, just pretend I'm rewriting the limit. That's horrible. I'm so sorry. You're going to have an h that can get rid of that denominator, and you end up with plugging in and solving for a little baby equation or constant. Does that make sense? Guys, I'm here during lunch or after school. Sorry about the computer, but hopefully we still got most of our questions answered. You can do this. You can do this. Keep praying, but you can do this. Huh? Yeah. Yeah, of course.